Hi there, exercise 16. Now we're going to look again at conditional probabilities. Now these we saw in year 12, not particularly directly in terms of, I remember showing you a notation which was on the lines of the probability of A given B. This word here is the conditional bit. It is said given. It's written as just a straight line, or sometimes a sloping line, sometimes more written like that. But the idea is it's the probability that A happens, given that we know that B definitely happens as well. So that almost constrains what can happen to A, because B has already happened. And that changes the probability, and that's what we're going to play around with today. We'll start then, first of all. There are 4 red and 7 blue pens in a drawer. Pens are taken out at random without replacement. Now, without replacement basically means they don't get put back. So what's the probability that the second pen is red, given that the first pen was blue? Now obviously I'm using the word given just to remind you of what it means. So the probability the second pen is red, given that, so if the first pen is blue, I've only got 6 left. That's basically the idea. The probability then that the second one is red presumably is 4 out of the 10 that are left, and that's 2/5. Alternatively, what's the probability that the third pen is blue, given that the first 2 that were taken were red? Right, so this is back to 7 again, and the first 2 were red, so presumably I've only got 2 of those left now. I've got 7 blues still. What's the probability the next one is blue? Well, that's, I think, 7 out of 9. So this is a reminder, really, 4 out of 10, 7 out of 9, yes. This is a reminder, really, of the word given. Basically, something's happened, and our job is now to calculate another probability based on the fact that that has happened. A little reminder, mutually exclusive events. These, again, we come across this phrase at GCSE in a limited sense, and certainly last year in year 12 we saw it in a more detailed way. It refers to the idea that 2 events can't happen at the same time. If they can't happen at the same time, they are mutually exclusive. If they can happen at the same time, they are not mutually exclusive. So A, it will rain tomorrow, B, it will be sunny tomorrow. Now, presumably it can be both rainy and sunny. So these events are not mutually exclusive. That's the... So okay, let's have a look at set notation again. We saw a bit of this again at year 12. I'd like to point out first of all the 2 symbols that we used in A12. This symbol now, which I'm drawing, is like an N. Technically it's the intersection, and it means and. So A intersection B is really, we call it A and B. And you can see the N in both of them, which helps. The word for or the symbol for or rather, is like the union symbol, and that's a big U. Now obviously it doesn't look like an O or an R, but it's the opposite one. And the other one I want you to highlight is, which you may not have seen before, you probably have, A complement they call it, which is basically not. So if A is not going to happen, we're at A dash, not A. A complement is the easiest way of describing it. So the Venn diagrams show you this as well. I quite like Venn diagrams. So this is meant to be the intersection of A and B. You can see there's A, there's B. Where does both A and B happen? A and B both happen in this section here, and so that's why it's the intersection of. And it's a smaller amount than A or B because they've both got to occur. So if you want to have an example, it might be the probability I get rich tomorrow, and B might be the probability that I don't know, I get great grades in my A levels. Now the probability of getting rich tomorrow and getting great grades, well, both quite unlikely for a lot of people. So the probability of them both happening, well, this is really unlikely now. Getting rich and getting great grades, even less likely. Whereas, if I said the same thing, there's a chance of me getting rich, and there's a chance of me getting good grades. What's the chance of one of them happening? Either or both, perhaps. But you can see now I've got this chance, and I've got this chance, and effectively I've got a bigger chance of one of them happening, or both happening. This is, as I said, this is the probability of A. This is really the probability that A doesn't happen. You can see, really, all you do in this is the probability of A not happening is 1 minus the probability that A happens, because obviously they all add up to 1. Alright then, so now we've got this question. I'll just get my pen back. We've got a question on probability, and I just want to remind you before I have a look at this, is this formula we saw at GCSE, well, very little, but definitely at A-level in year 12 we saw it properly. And it was this formula which basically said the probability of A or B happening is now not quite so easy as it was at GCSE. At GCSE you probably saw this formula a lot. The probability of A or B is the probability of one plus the probability of other. And most students, I think, probably would have been, that was the limit of what they got taught. Now it's not always true. This is only true when the events are mutually exclusive. So when they're mutually exclusive it works, but when it's not mutually exclusive events, we got this additional add-on bit. You can see this bit here at the end. So make sure you write this formula down. It basically says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B both happen at the same time. Now if they can't both happen at the same time, this part of it effectively disappears. But if they can happen at the same time, if the events are not mutually exclusive, then you've got to take this extra bit into account. So I want to show you an example of this, which is very similar to one I showed you at year 12. So we've got this spinner game. You can see it either spins in the inner section or the outer section. The fireman game, I've called it. And you can see initially it's landed, it seems to have landed in 2 and red. And the question says, what's the probability if I spun this, it lands in 2? Now if I just look around there, I don't think the outer bit matters if I'm just thinking about 2. There's 2 sections and there's 6 altogether, so I think that's 2 out of 6, which is a third, which is nice enough. Probability that you rush to the building, I've said it's the green bit. So if I do rush to the building, there's 1, 2, 3, 4. And again, I don't think that matters about the inner bit because I'm only doing the outer bit now. So there's 4 ways to get that. Out of the 12 ways in total, 4 out of 12 is a third. I like that. Now, I now look at this again then. So I'm now looking at what's the probability of getting 2 or rush to the building. 2 or rush to the building. Well, I suppose this section here would count. So this is 2 or, it's not rush to the building, but it is 2. So that section there, if it landed there, would count. And this section here, if it landed here instead, that's blue, that's 3. That would be neither. If it lands in there, or as long as it's green, it's okay. Yeah, that's all right. That would be a tick. If the spinner landed here, no, that's no good, because it needs to be 2 or rush to the building. 2 or rush to the building, no. 2, actually, in that one, it's both of them. Both 2 and rush to the building. Here, I've got 2 and I've got red, oh, that's okay. Here I've got 3 and I've got yellow. And no, that's no good. But oh, this is alright. Green. 1 and no, that's no good. 1 and no, no good. 2 and that one again, the 2 and the green appears twice. So on that basis, how many have I got? 1, 2, 3, 4, 5. I've got 6 out of 12, which is half. And notice, if I just added them like my formula at GCSE, the probability of A or B, or in this case 2 or rush, would have been a third plus a third. Now a third plus a third is 2/3. And of course that is not equal to the answer I got, which was a half. So these are not mutually exclusive events because they happened at the same time. This overlapping of the events is what caused the problem. Okay, let's do these examples. A chocolate is selected randomly from a box. The probability of it containing nuts is a quarter. So I'm just going to write the probability of nuts is a quarter. Probability of containing caramel is a third. Both of them, nuts and caramel, is a sixth. What's the probability of it containing either nuts or caramel or both? Well, probability of it contains nuts or caramel. This is or. This is. Now notice I had a formula. and it basically said A or B is the probability of one, so that's a quarter, plus a probability of the other, that's a third, minus the probability they both occur. I think it's just that. That's all I think I've got to do. And if I do that and put them all over 12, that gives me, I think, 5/12. Type that in. See what the answer says at the bottom. 5/12, yes. Next example, a new probability formula. This is a formula which is important that we suss. It's the probability of A given B. I've already described what this means. It's called probability. Now, you'll notice it's a restricted probability. So this is the probability that A occurs. So in here, given that it occurs, B occurs. So effectively, I've got a much reduced restriction. It's that out of all of it, because A can't occur on its own. B has to occur as well. There is a formula for this. The probability of A given B. Notice the given bit is the B bit, is equal to the probability they both occur, the probability of A and B, so like this red bit, divided by the probability of B, all of this bit. Notice the B there, and the B is the bit on the bottom. So the given bit is the bit that's on the bottom. Now, let's use that formula to do this question. It says, find the probability of B given A. Well, look at that, me being naughty. I've switched the letters around, so I better rewrite this formula. It's the probability of both of them happening, B and A. B and A is really the same as A and B, so it doesn't matter which way around you write that, divided by the second one, probability of A. So we've got all this information. I know this is 0.42 divided by the probability of A is 0.72. So what is 0.42 divided by 0.72? My calculator says 0.583, or 7/12 if I want it as a fraction, which I probably do. 7/12 is the answer. Notice I got given a load of information. My formula just told me to use two of them. 3 examples for us to do. I want you to have a go at these. I think some of this has moved around actually. Now, a couple of examples for us. This first one, I've quickly tried to summarize it. It's the probability that someone is a millionaire is 1 in 10,000. The probability they live in a mansion is 1 in 30,000. The probability that both occur is 1 in 40,000. That's really what this all says here. And the question says, what's the probability that we pick someone in this city in Japan that they will be a millionaire given that they live in a mansion? Now, my formula says basically I do the probability of both of these things happening. So it's the probability of millionaire and they live in a mansion. And then you divide by the probability they live in a mansion. So I think that is 1 in 40,000 divided by they live in a mansion, 1 in 30,000. And I reckon if you put that in your calculator, you'll get 3/4. The second question says the probability. Alright, now first of all it says probability of A or B not happening. Now just bear in mind, if it doesn't happen, to get the probability that it does happen is 1 minus it. So that's got to be 7/12. So just bear that in mind. I think that's important because we're going to use, to find the probability of A and B, we will need to use the probability of A or B is the probability of one plus the probability of the other minus the probability of them both. Now that's actually the thing I want. If I just put my numbers into this, A or B, then it's, I think, 7/12 equals a half plus a quarter minus the thing I want. So I think I can move that over. Half plus a quarter is 3/4, which is 9/12. I reckon this is 2/12, which is a sixth. I don't think we've got much more time actually, so I won't try to do the last one, but I think a sixth for that, and I've said 3/4 for that. And well, at least I've got that. So we'll finish off those other parts, then for instance this part and this part in class, and then I'll talk about a couple of other things, and then we'll do exercise 16a. Look, that should be a good introduction to what we're doing, but obviously we're getting used to a new formula, and that will take a bit of time. Practice is required. But other than that, thank you very much.